papers in my notebook.
5.1, use properties of exponents.
Exponents. Oh, wait, now I know what that is.
There's a lovely green poster on the wall that has properties of exponents on it if you happen to forget them.
Whoa.
They are there.
Oh, 5 is just exponents now?
I'm kind of. I think it's funny because, like, the other algebra class is probably thinking, like, oh, hey, we already did this. We're cool.
Alright, so I'm going to make
I'm just gonna start doing it.
property name. There's 7 of them.
7.
Alright, so the first one, the property name is product of powers. So this one says that a to the m times a to the n is equal to a to the m plus n. So if you're multiplying two things that have the same base, you add the exponents. Next one is power of a power. This one says that a to the m raised to the n is equal to a to the m times n. So if you raise something with an exponent to an exponent, you multiply the exponents together.
I have a question on that. So for the product of powers, would you multiply the base number too, or just add the exponent?
Nope, it's literally just you keep the number at the bottom. It has to be the same base. It's like they both have to be whatever that number is to do that. All right, then power of a product. This one says that a times b raised to the m is equal to a to the m times b to the m. This is like distribution, basically. Next we have negative exponent. Okay, we don't like negative exponents.
No. Is that what we like?
A to the minus m is equal to 1 over a to the m, given that a is not equal to 0, okay, because obviously you can't divide by 0. I'm going to make a little note down here for negative exponents. This is a Mr. Cassism. Okay, we're gonna come back to that in just a second. Put it where it ain't. Make it positive. Okay, because we don't like negative exponents, so he always said, put it where it ain't, make it positive. I know it's not grammatically correct, but I never forgot it.
We're not missing that.
Yes, exactly. But it's a Mr. Cassism. So if it was on the bottom, you would do the same thing to move it to the top. If it was like 1 over a to the negative m, it would be a to the m would be what it would be equal to. All right, going back, 0 exponent. a to the 0 is equal to 1, and again, given that a is not equal to 0. If a is 0, we have bigger problems that you don't know about till calculus. Next one is quotient of powers. So this is a to the m divided by a to the n, or all over.
All over.
Equals
Can't fit all over it.
a. I was joking.
Better.
A to the m minus n. So we would, okay, the same, so the opposite of the negative exponent thing applies as well, okay? If it was on the bottom and you want to move it to the top, okay, you have to make it negative to move it, okay, if it was positive. So that's why the quotient of power rule works. And again, we still have a not equal to 0 for this one. And then lastly, the power of a quotient. We have a over b raised to the m is equal to a to the m over b to the m for b not equal to 0. Okay, scientific notation is also included in this section.
Oh.
No.
But y'all know about scientific notation, so I'm not really going to give you any notes on scientific notation. You'll just see it when we get there. In the book, it may ask you to tell the property name for what you're using to do these problems. That's a bit excessive, so we're not going to do that. You're just going to solve the problem.
Okay.
You don't need to tell me what property you're using to solve a problem. It's just not necessary. So, okay, that's all the notes.